Welcome. I'm Matthias Endler and this is Hello Rust. Today we talk about Python and Rust. The reason why I want to talk about it is that I have a Python background and I did a lot with Python in the past, and there are some similarities and there are some differences between Python and Rust. And there's only one thing I want to focus on today, which are list comprehensions. So if you're familiar with Python, then usually you know what it is, but if you're not, then I will show you a few examples and then we port this code to Rust and see the differences and the commonalities. But before we start, shout out to Darren Gordon who suggested that on the Hello Rust show GitHub repository, and you can also suggest some new episode. Just open a ticket or upvote the existing tickets. Yeah, so let's get cracking. First, we look at Python. List comprehensions come in handy when you have a pattern like the following. Let's say you have a list of numbers and you want to fill it with, some numbers. You say for I in range 1 to 1000, numbers append I. This would create a list of, the first couple numbers. So let's print it and run this. You have some numbers. Wow. Instead, what you usually can do is you say numbers equals I for I in range 1 to 1000. And if you then print the numbers, you have exactly the same output. Quite nice. In Rust, on the other hand, usually you don't work with list comprehensions because they are not available. Instead, you use something like iteration, filters, and maps, and maybe a collect. Let me show you what I mean. So to recreate the same functionality that we have in Python with our numbers thing, let's create the same structure. So we say let numbers equals, and then we need maybe an empty vector for I in 1 to 1000 numbers dot push I. And it needs to be mutable. Let's print this. And of course, we need to use debug output because there is no real representation for vectors out of the box. And we get our list back. But maybe we don't want to create this temporary variable here, the numbers, and we want to iterate over the numbers and collect right into some kind of vector. Let's do that. So let numbers is not this, it is the range, and then for each element we iterate over it, and I guess we can simply collect into a vector of I64, for example. Don't forget the brackets here. Nice. So let's switch back to Python for some more examples. On many Unix machines there is a dictionary of English words. And I like to play with that. So a way to load that in Python might look like this. You say with open, and then you give it the path to the dictionary as f for line in f, print line. And if we run that, we get a lot of words. Not really helpful. Also, the terminal doesn't stop. It should stop. Okay, I killed it. Anyway, so let's rewrite that into some kind of list comprehension. Words equals word for word in open blah. Print words. It doesn't stop again. I guess that's one thing you would do differently in Rust. Let me show you how. One thing to look at for very common tasks like this is the Rust cookbook. And you can see that there is already some sample code that we can use to read the words from a file. So I will just copy that and modify it a little bit, and let's copy that in. I don't want this here, I want that on top. I don't want the run method, actually we just unwrap. This will be our path again, that I forgot. Where is it? Yeah, here. Oh Lord. And we don't create it, we open it instead, and we print it, and the question marks need to be replaced with an unwrap since we are in the main function. Does that look good? Nope. What's wrong? Ah, okay. I also forgot an unwrap here. And I got my word list back, and the terminal doesn't stop again. And once again, we want to collect this into a vector now. Let lines equals buffered lines collect and a vector of string. And here we see the first significant difference between Python and Rust in terms of error handling. While Python just throws an exception when a file is not available, Rust lets you handle that. And you need to decide what to do in this case. So one way to do things is just to unwrap and die whenever something weird happens, or you handle the error. You can also filter out errors. And the way you do that is with some kind of iterator pattern. The only thing you need to do is adding a filter map and filter the results based on result OK. What this means is give me all the elements in my iterator, and for each ones map it to some kind of operation. And if the operation does not yield a result OK value, then drop this value and collect only the ones that actually are OK. And if we run this, we get no output because obviously we print nothing. But if we do, we get a bunch of words. It's now much faster, but it still blocks my terminal. Of course, you can be so fancy and now concatenate that all into one line, and it's a really bad idea, but let's do this. So you say, give me this. Oh. Give me this. Put it here. Unwrap, yeah. And then you say, put a buff reader around it. And we iterate over the lines. And we filter. Does it make sense? No. Because now we need to specify the type as well. We can now also specify an underscore, which means we don't care. And we get a bunch of words. Switching all the way back to Python. Now I show you something even cooler in Python, because you don't need to collect into a list. You can also collect into other data structures like a hash map or a set. And let's say, for example, you want a dictionary of a word and the length for some reason. Let's take our word list and create a dictionary from that. So you say word lengths equals, and then you create a dictionary and you say word and length of the word for word in words. And let's print that. Do I want to print that? Ah, come on. Lengths. Damn it, I can't type. Same thing can be done in Rust. Let's rename this to words. And now let's iterate over the words and calculate the length and collect it into the word's length hash map. So let words length is a hash map of type string and I64 maybe, and that is words.iter dot map word, and we return a tuple of word and word.length and collect it, and we need to use std collections hash map, and let's print it. Data types are wrong, so we don't care about this, and we say usize. We get our weird looking hash map. Switching right back to Python. I'm not really interested in a single word. I'm more interested in all the words that have one length for some reason. In Python, that is quite simple. You start with a default dictionary, which is a dictionary which will be initialized with some empty value if a key is not existing yet. So you say word, yeah, let's call it word lengths, why not? And that is a default dict. I guess it's also in collections. And this default dict will be initialized with a set, because our words don't really have an order, so we care more about is a word in set or not. And whenever there's an empty key, actually whenever there's an empty value, it will be initialized to an empty set. Rename that to word dict and say word lengths at the position of the length of the word dot append word. And let's print the dict. Set has no attribute append. That's because it's add. And it's none. Okay, after some more thinking, I realized this was a stupid idea. Why not use a simple for loop for something that is a simple for loop? So we can say for word in words, word lengths at length of word dot add word. Let's say this. Okay, I will execute it and terminal will die again, of course. But you need to believe me that now everything is ordered in the lengths of the words. Same thing in Rust. Okay, we have our words here and we want to have a hash map. Let word lengths, let's remove that, and we say hash map of the U64 maybe, usize and something, and that is words.iter.map and word, and we say length of word dot collect. Well, that won't work because we iterate over that thing and then we map it and then yeah, we collect that into some kind of hash map, but we override the values that are already existing in that thing. So if we run it, word length, that's correct. And too much Python. You can see that we only have one word per character count. And a way to do that ergonomically in Rust is to use the entry API. Now let's look up the documentation for the Rust entry API. The entry is an enum and it has two variants. One is occupied and the other one is vacant. And this concept alone helps us a lot when mutating a data structure and appending while we iterate over something. This is a bit like our default dict in Python. I wouldn't use iteration and filter and map and reduce in Rust anymore. I would just write a simple iteration over our vector of words and then insert it into our dictionary. A bit like this. So we say let word length equals hash map. We can keep the type. Yeah. Hash map new. Let's define the type here. And we iterate over our word. And words. Dot, yeah. And then we say word length. Oh, running out of storage. We have word length dot, what was it? Entry. And the entry will be word dot length dot or insert. We give it an empty hash set. Let's import that real quick. And then we get a pointer back, and we can modify that pointer by saying first we need to dereference it. And then we say push word. And what's wrong? Yeah, we cannot format. No. I need some more parentheses here. No. Yeah, and push is not found for this type of data structure. I guess it's not push, it's add. Okay, I shouldn't guess. Let's see. Oh, by the way, since I'm already at it, this is a wonderful application called DevDocs, and it shows you documentation about Rust, and yeah, it's offline, so you can take it wherever you want. It's free, you can download it from GitHub, and I can highly recommend it. It's very easy to find things, and yeah, you see, when you're struggling, you just look at the docs. And it's not push, it's called insert. And we get a type bool back. So in fact we don't need to dereference it, but our vector needs to be mutable. And then we get our list of words back. And it's a long, long list of words. Just for a quick check, let's print all the words with length 3. Yeah, 3 as, oops, 3 as usize. Oh, I guess a borrow of 3. Yeah, and we get some nice short words back. I guess that's it. And I guess that's already the end of the show. So if you liked what I showed you and you liked the show in general, then I would be very happy if you could subscribe to the YouTube channel. Also, of course, if you have some time, please consider donating to Patreon. I will donate 50% of all the money I get to the people behind open source, and the rest of the money will go to better audio and video equipment. Yeah, so that said, I hope you had some fun and see you next time.